Now for one more applied problem, shape of a hemispherical bowl. Think of a basketball cut in half, like a bowl that holds chips for a party. Okay, and the bowl, it says, of course, is hemispherical, and it's filled with water to a depth of 3 inches, and so that's labeled in the figure as H, but H is 3 inches. And the radius of the bowl, in other words, the radius of the hemisphere, is capital R. Express the radius of the bowl as a function of the angle theta, where the angle theta is made with the radius of the water and the radius of the bowl, and it is an acute angle. Okay, so now one thing I can notice is that anywhere you go from the center of the bowl to the side of the bowl is the radius. So this height would be the radius minus 3. Now what you want to end up with is r as a function of theta. So you want r of theta equals. So you expect a formula involving theta. We've practiced this before when we looked at setting up functions. Okay, now what I see is the angle theta here in a right triangle, where the side opposite theta is capital R minus 3 and the hypotenuse is capital R. This naturally lends itself to using the sine function. So sine of theta is the ratio R minus 3 to R. But remember, you want R in terms of theta, so you want to solve for R. This just takes a little bit of patience. But let's go back to the basic premise here. If you have a right triangle and at least one side and an angle, you can solve the triangle. And here you had a similar situation. You had an angle and 2 sides to solve the triangle. So if I multiply both sides by r, I get r sine of theta equals r minus 3. I notice that this is linear in r. R is to the first power. So it would make sense to get all the r's on one side and anything that's not r on the other side. Then we can factor out the r. And divide. And we get the quotient negative 3 divided by sine of theta minus 1. Okay, now check this off your list. Is this r as a function of theta? And it is r equals a formula involving theta. Okay.